Okay, so good morning, everyone. Our discussion for today is Engineering Economics 2. So basically, in Engineering Economics 2, we'll discuss about the gradients, which are the uniform arithmetic and the geometric gradient. We will also discuss depreciation methods, the straight line, the service output, the working hours, the sum of years dated, the declining balance method. We also have double declining balance method. And finally, under depreciation, we'll discuss the sinking fund method. And we'll also discuss the concept of capitalized cost, the concept of annual cost, and the concept of bond. So I will start with the uniform arithmetic gradient. Okay, assuming that we are renting a warehouse and that our first payment will commence at the end of the year. Assuming that now is January 1. So since now is January 1, we'll not pay yet the rent for the year. At the end of the year, we'll pay our first payment. Assuming that the first payment is equal to 10,000 pesos. And the following year, the payment will increase. Say the owner of the warehouse charges an additional 2,000 pesos for every year. So meaning if the payment for this year is 10,000, then the payment for the next year will be 10,000 plus an additional 2,000 for a total of 12,000. That is, at the end of the third year, we'll have 10,000 plus 4,000. On the fourth year, we'll have 10,000 plus 6,000. So this type of cash flow will continue as long as we are renting the warehouse. Okay, so if this is 10,000, this yellow arrow represents our 2,000. Now we decided that we will pay all of our obligation now to the owner of the warehouse. So how much should be paid now? Okay, in order for us to compute the amount that is necessary to produce now in order to pay off all of these rent payments, say for n periods, we will compute the present worth of all of these cash flows. 1. It is clear that we have an ordinary annuity cash flow here, the red portion. The present worth of all of this cash flow is this formula. Next, we will calculate the present worth of all of these cash flows, which is represented by this increasing cash flow. The present worth of all of this cash flow is this formula, which is a complicated and monstrous formula, but we'll introduce another formula or method that will simplify this calculation. Okay, so in order to simplify our calculation, because I discourage depending on those formula because they are so complicated, we may use another technique to compute the present worth of this gradient. So here, at the first year, at the end of the first year, our payment is equal to 10,000. Let that be our A. Next, on the second year, our payment is 10,000 plus 2,000 is 12,000. Let that be A, which is 10,000, plus the gradient, which is 2,000, A plus G. And on the third year, our payment will be 10,000 plus 4,000. Let that be our A, which is 10,000 plus 2,000s. Okay, so on the fourth payment, our payment will be 10,000 plus 3 2,000s. Or in formula, we have A plus 3G. Okay, observe that the um, the coefficient of G here is always 1 less than the period. As you may observe, on the first payment, there is no G. In the second payment, there is 1 G. Second payment, 1 G. That is, the number of G is 1 less than the number of the period. In the fourth payment, the number of G is 3. This is third, but this is 4. That's why our formula here is A plus 3G. Now we can say that at the 11th payment, the amount of payment at that period must be equal to 10,000 plus the increase in the payment. The number of gradient that has increased in this time is equal to 10 because the number of the period here is 11, so our gradients must be 1 less than the period, which is equal to 10. So we'll have 10 plus 2 times 10, or in general, if this period is on X, year X, then our cash flow at that time will be equal to A plus G. And the number of G is equal to 1 less than the number of the period. Okay, using this quantity, we can determine the present worth of this cash flow by dividing it by the present worth factor of a single payment. Okay, as you may observe that this quantity is not difficult to recall. For arithmetic gradient, the cash flow is simply the arithmetic series formula. The first element is A plus the common difference is G times n minus 1. This is the equivalent for the arithmetic series formula. So to compute for the present worth of this quantity, we divide it by 1 plus I raised to x, because this is x years from year 0. The quantity 1 plus I raised to x is called the present worth factor of a single payment. Now, because recall that from our compounding formula, if we have a given future amount f, we can determine its equivalent present worth by dividing it by this quantity. Now, in our cash flow, what we have is the single payment A plus G times X minus 1. Then, in order for us to determine its equivalent payment now, we divide it by this factor. So dividing it by this factor, then we get the present worth equivalent of that cash flow. Okay, so in order for us to determine the present worth of all of these cash flows, we simply replace our X here by 1, 2, 3, up to n. Or in short, we will use the function of the calculator, which is the summation function. We will let the calculator compute the sum of all of this expression while substituting 1 up to n for our x. So instead of using the long formula, the formula for the annuity and the gradient, we can use the simple formula for the computation of the present worth of the arithmetic gradient. Okay, let's try this problem. Find the present worth of all cash disbursements using gradient interest formula if money is worth 15% per annum. Annual cash disbursements increases by 1,000 every year. thereafter until the end of the fourth year. The first cash disbursements amounts to 5,000. So we'll use this formula. Our first cash flow is 5,000. The increase in cash flow is 1,000 times the variable x, and then we compute the summation. Okay, take note that if the cash flow is increasing, the sign of G is a plus. But if the cash flow is decreasing, the sign of G is a minus. So we have already a complete value here with an interest of 15%. Our N is 4. Our A is 5,000. Our G is 1,000. Our I is 0.15. So substituting everything to the equation, we get the present worth of the cash disbursement. Okay, let's now proceed to the geometric gradient. Assuming that the rent in the house or the rent of the warehouse is increasing in a fixed percentage, assuming that at the end of the year the rent is 10,000 pesos, and the owner of the warehouse decided to increase the rent by 20% every year based on the previous rent amount. So since the rent amount at the end of the first year is 10,000, then increasing 20%, let's say the increase is 20%, then the new rent must be equal to 10 times 1.2 for that year, or 12,000 for that year. Now, since this is the rent for the previous year with respect to the third year, then on the third year the rent must be equal to this quantity times 1.2. Since we already have two 1.2s, then we have 1.2 squared times 10,000. So if we are to compute the rent for the 11th year, then we can say that this rent amount must be equal to 10 times 1.2, and there are 10 1.2s. Okay, as you may observe again, that the number of 1.2 is one less than that year. So our exponent here is always one less than the period. Okay, or in general, we can say that the cash flow at any period is equal to the initial cash flow A times 1 plus the gradient, the increase. If the cash flow decreases by some percentage, the sign of G is a minus instead of plus. So if it is a minus, then the resulting value here is 0.8 instead of 1.2, because 1 minus 0.2 is 0.8. But since this is a plus, that's why we have 1.2. So our formula here is A times 1 plus or minus G or raised to the power of x minus 1. Now, to compute the present worth of this quantity, we divide it by the present worth factor of the single payment, and this is that quantity. So, any cash flow on the X period divided by the present worth factor, then we compute the present worth of that cash flow. And then substituting the value of 1 up to n, we'll get the total amount of the present worth of all of these cash flows. So this is the formula to compute for the present worth of the geometric gradient. Okay, as you may observe, I did not introduce the future worth formula for the arithmetic and the geometric gradient, because the future worth equivalent of this cash flow may be determined by computing the present worth cash flow first and then projecting it to the future by multiplying it by 1 plus I raised to the power of n. Okay, so let's proceed. A newly acquired machine requires an annual maintenance cost of 10,000 pesos. If the annual maintenance costs is increased by 20% each year for 10 years, what is the estimated present worth of the costs if money is worth 15%? Okay, so here is our formula to compute for the present worth of any of the maintenance cost. So to compute the present worth of all of the maintenance cost, we simply input this expression in the calculator under the summation function. Okay, where our first cost is 10,000 pesos. The increase in the cost is 20% and the worth of money is 15% and the number of years for the maintenance is 10 years. So computing for the value of the present worth of all of the costs will get 106,101. Okay, we will develop a feeling of what is meant by 106,101. We know that 106,101 is the estimated present worth of the costs, meaning this is the equivalent of all of the costs starting the end of this year up to the end of the 10th year. We have now the present worth of the costs. So what does it mean by 106,101? Or how do you feel that amount? Okay, I will illustrate the meaning and the concept or the feeling of what is meant by 106,101. It means that the amount of 106,101 is the only amount you need now in order to provide all the maintenance costs from the end of this year up to the end of the 10th year. Imagine now that you have 106,101. Since this is the beginning of the year, year 0, January 1, then you don't have maintenance cost, meaning you will not withdraw amount from this amount. So meaning at the end, meaning by now, the amount of money is 106,101 and it is in your pocket. Assuming that this money is deposited in the bank, because this problem states that the worth of money is 15%. So meaning there is an available opportunity around that is capable of increasing your money by 15% yearly. So now is January 1. We will deposit this money in the bank such that it will earn 15% yearly. Okay, so now I deposited it in the bank and at the end of year 1, it accumulates and it becomes 122,116. Verify that when we multiply 106,101 by 1.15, that is the amount after a year in the bank, is exactly or about 122,016. Now, since this is at the end of the year, you go to the bank and withdraw an amount for your first maintenance. The amount to be withdrawn is 10,000 pesos. After withdrawing 10,000 pesos, the balance of your money in the bank is 112,016. And then this amount of money will continue earning an interest of 15%. That means when we multiply this money by 1.15, at the end of the second year, this amount of money will become 128,819. And then you go to the bank to withdraw your second maintenance cost. You withdraw how much? Well, because the maintenance cost also increases each year by 20%, then we need to multiply 10,000 by 1.2 to get the monthly or the equivalent maintenance cost on the end of the second year. That is 12,000. Deducting 12,000 from the balance in the bank will get 116,819. Now, we continue the process up to the 10th year. So here, we multiply again this amount by 1.15 and we get 134,341. And then we withdraw amount for the maintenance cost. 12,000 increased by 20%, that is 12,000 times 1.2, we get 14,400. Deducting 14,400 from the available balance in the bank, we'll get 119,910, and so on and so forth up to the 10th year. At the end of the 10th year, the amount of money in the bank, including its interest, is 51,600. You withdraw a maintenance cost amounting to 51,600. The remaining balance is zero. Now, as you can see, the only amount of money that you have now is only 106,101. No more, no less. That is the only amount of money that you needed in order to provide all the maintenance costs from year 1 up to the year 10. That is what is meant by the present worth of the maintenance cost, meaning the amount of 106,101 is equivalent to 10,000 for the first year, increasing 20% for each year for 10 years, for a worth of money of 15%. Okay, so we'll now proceed to the method of depreciation. Depreciation has many methods, but in this lecture, we'll first illustrate the simplest of them all, the linear method of depreciation. Assuming that you have a new phone, you bought a phone for a cost of 11,000 pesos. We represent it by a variable CO to means the cost at year zero or cost now. When you buy the phone, the cost of the phone is 11,000 pesos. That is the brand new cost. Now, when you buy the phone, what you really bought are the cost of service. But when you buy the phone, you buy the phone for the purpose of course, communication, scrolling your Facebook, making text messages and calls, meaning you buy the phone for the purpose of the services. But the phone cannot exist without the metals, the plastics, and the rubber in it. So meaning when we buy the phone, we buy two components. One, we buy the plastics and the metals and other materials in the phone. Assuming that this phone is good for 10 years. After 10 years, it's no more capable of delivering a service. And say that since the phone is composed, or since you buy the phone, you buy the services and the plastics in the phone. Assuming that this portion represents the cost due to the materials in the phone, the plastic, the metals, and the rubber, and assuming this is worth 1,000 pesos, that is CL, meaning the cost after its lifetime, which is sometimes called the salvage value. Well, the salvage value refers to the cost of the materials in it. Okay, so since the cost of the materials in this phone is 1,000, it means that 11,000, from 11,000, 1,000 of which is for the plastic and metals. The rest, which is 10,000, that is the cost original or the cost of the phone, minus the salvage value, meaning the cost of the plastics, is 10,000. The 10,000 in this uh, cost represents the cost of services. This is the cost of the phone, which is the majority cost of your asset. Now, here is the schedule of depreciation of our phone. The phone will depreciate according to this schedule. But let us first discuss what is to be depreciated. As you can see, the depreciation must affect only the services. It will never affect the metals in the phone. The metals and the plastics in the phone are not depreciated because they do not depreciate, meaning they do not disappear, they do not degrade, they do not disintegrate. Only the services that uh, only the services that are depreciating. Okay, let me illustrate why. At year zero, that is now, the cost of the phone is 11,000 pesos. It has not depreciated yet because we have just bought the phone now. So, the book value or the price of an asset at any period, book value, is 11,000 pesos. Now, a year later, a portion of the services has depreciated. A year later, the phone has depreciated by 1,000 pesos, and the remaining amount or the cost of the phone is 10,000 pesos. As you can see from here in our illustration that the service has depreciated. We have deducted some amount in here. And then on the second year, another 1,000 pesos has depreciated, leaving only 9,000 pesos as the book value. And on the third year, the fourth, the fifth, sixth, seventh, eighth year, ninth year. And on the ninth year, another 1,000 pesos has depreciated, leaving only 2,000 pesos as the book value. Now refer to our diagram or illustration here. There is only a small portion left for our service. The phone, after 9 years, is still capable of performing of some of its tasks or services. That is why when you sell the phone by that time, the cost must be the cost available or the cost equivalent to its service plus the cost of the plastics and metals in it, which is intact at 1,000 pesos. So 1,000 plus 1,000 is 2,000. Now, a year later, the cell phone is no more capable of delivering its service because maybe the remaining keypad has already collapsed and it is no more capable of sending messages or whatever services. So at the end of the year, it has depreciated another 1,000. The cost of service has totally depreciated. Here, this is a total of 10,000 because the cost of service is 10,000, leaving only 1,000, which is the cost of the plastics and the metals. Okay, so let us now illustrate how did we determine 1,000. Here you can deduce why the depreciation for every year is 1,000. It is because the life of the machine or the life of the asset is 10 years and its cost of service is 10,000. Then if we distribute equally its life for 10 years, then each year would get 1,000. If we determine the depreciation rate, it is so simple. Based on the cost of service of 10,000 in the life of 10 years, we simply distribute the cost of life or the cost of service for its life of 10 years. That is dividing it by the life, which is 10, then we get 1,000. 1,000 is the rate of depreciation per year. Now, if we ask, how, this is the formula now for the depreciation. Now, if we ask, after after 5 years, how much amount has depreciated? So since the depreciation for every year is 1,000, it means that for the period of 5 years, the total depreciation must be equal to 5,000. It means that we can write that the formula for the total depreciation is the depreciation per year times the total number of years. Or in general, the depreciation per period times the total number of periods. This is the formula for the total depreciation after some n years. So now, if we ask, what is now the book value? It is so easy to determine because if the total amount that has depreciated is 5,000 and the original amount is 11,000, meaning deducting 5,000 from the original cost, then that will be the cost of the phone now if sold. Then this formula is the formula for the book value. Original cost less depreciation. Okay, let's try this problem. A machine which costs 10,000 was sold as scrapped after being used for 10 years. If the scrap value was 500, determine the book value at the end of the 5th year. Okay, we're going to determine the book value at the end of the 5th year. But first, we need to determine the rate of depreciation. Okay, the original cost of this machine is 10,000. The life is 10 years. The cost of plastics and metals or the salvage value or the scrap value is 500. Meaning, we can determine the cost of its service, which is 9,500 because 10,000, the total cost of the machine, less the cost of the plastics, the metals, and anything in it is 9,500. Now, if we distribute 9,500 equally throughout the year of its life, then we'll get 950. This is the depreciation per year. Now, if we compute the total depreciation, we multiply it by the number of years. Since we want to determine the total amount depreciated after 5 years, then we'll have a total depreciation of 4,750. Now it's time to determine the book value. To determine the book value after 5 years, we simply compute the difference between the original cost and the total amount depreciated, and we get 6,250. By the way, there is also a method to compute the book value and the depreciation using the calculator technique under the statistics function, but due to the limitation of this PowerPoint, I cannot illustrate it here. But anyway, the best thing is to understand the concept of depreciation because whenever the question is rephrased or whatever scenario, we can still answer the question. Okay, let's proceed with another method of depreciation. This now is called the service output. Assuming we have a photocopier which costs 11,000 pesos. This photocopier is capable of printing 10 units, assuming that per unit or a unit of this work or output is equivalent to 1,000 or 1 million pages, meaning after printing 1 million of pages, it means that the photocopier has printed 1 unit. And this photocopier is capable of printing 10 units, that means 10 million of pages. After printing 10 units, this photocopier will totally maybe disintegrate and then not capable of delivering its service. So it will totally worn out after printing 10 units. Okay, so since this photocopier cost 11,000 is composed of the plastics and the metals in it, then if the cost of plastics and metals in it is 1,000, then the cost due to its service is equal to 10,000 pesos. Now, if we compute the rate of depreciation for this machine, let's again refer to this depreciation schedule. Now, the machine is new, it is not yet depreciated. If you resell it by now, the cost is again the same, 11,000 pesos. Today, maybe you printed, for example, 1 million pages or 1 unit. After printing 1 unit, the machine would depreciate 1,000 pesos. The book value will now be 10,000. And then after printing another 1 unit, another 1,000 has depreciated, leaving only a book value of 9,000. As you can observe from the diagram, we have already 2 units printed and equivalent to 2 depreciation here. And on the third unit, take note that this printing or this depreciation is irrespective of the life of the machine. Meaning, if the machine is not used, then the machine is not depreciated. If we are only strict to the service output, but that is not the case. Because if the machine is not used, the machine will normally corrode, meaning the machine will depreciate based on life. Or when we say based on life, the machine will depreciate based on the linear method. Okay, after fourth unit of printing, it has depreciated another 1,000, another 1,000 for another unit, and so on, and so on, and until printing the ninth unit of papers. The machine has depreciated 1,000 and the book value is now 2,000. The machine is now in critical state because after printing or maybe printing another more, it will now totally disintegrate. Maybe the bolt are now lost and um, it has some damages already on the machine. And then finally, after printing the last unit, the machine has totally depreciated and it is no more capable of printing. As you can observe, this illustration is similar to our linear method of depreciation. The depreciation per unit is 1,000. Why 1,000? Because the total life of the machine or the service is 10,000 and it's capable of printing 10 units, meaning each unit is equivalent to 1,000 depreciation. Okay, so what's the formula is just the same. First, we determine the total service life or cost of service of the machine, divide it by total service output. The total service output in this case is 10 units, meaning it is depreciating at the rate of 1,000 pesos per unit of service output. This is the formula, and this is exactly the same as the formula for the linear method of depreciation, because the service output method is simply a linear method of depreciation only based on the unit output or on the work output. Now, if we ask what will be the cost of this photocopier after printing 5 units? Well, we multiply 1000 by 5 to get the total amount depreciated. Then we can say that the total amount depreciated is 5000. This is the same formula as of our linear method of depreciation. Now we ask again, how much is the machine after printing 5 units? Then we'll have 11,000 less 5,000, 6,000. This is the book value of the photocopier after printing 5 units. Okay, consider another method of depreciation. This time is the working hours method. Okay, recall we have the linear method of depreciation. The linear method of depreciation is a depreciation based on life. It means that our machine will normally depreciate because it will age, it will corrode, regardless of not performing a work or not working at all. Consider here another photocopier. The cost of this photocopier is 11,000 pesos. And this photocopier is capable of delivering service continuously in a continuous of 10,000 hours. That's why we are referring to this depreciation as the working hour method, because the life of the machine is based on the actual hours worked or performed. After working for 10,000 hours, this photocopier will disintegrate maybe and no more capable of delivering the service. So, if we compute the cost of service of this photocopier, we need first to determine the cost of plastics and metals in assuming that it is equal to 1,000 pesos. So the cost of service, its capacity to deliver its service of printing is 10,000 pesos. Now, if we compute the rate of depreciation, we divide its cost of service by its life in terms of the working hours. By the way, it is not life, although the variable we use in this case is L to mean life. It simply means that the total number of hours of this photocopier when delivering the service. So, here is now the depreciation schedule for this photocopier. Now, we have not yet printed any paper, so the book value of the photocopier is intact at 11,000 pesos. Now, after printing for the first 1,000 hours, we have a depreciation of 1,000 pesos. Another 1,000 hours of printing, another 1,000 pesos has depreciated, and so on up to the ninth 1,000 hours of printing. Printing another 1,000 more, it now has totally consumed the services, leaving only the plastics and metals in the photocopier. Now, how did we know that the cost of depreciation for every 1,000 hours is also 1,000? Well, that will be very because we can uh, deduce that from here. 10,000 is the cost of service. If we divide it by its working hours, I'm sorry, this is not linear, it is working hours. Divide it by 10,000, that is the working hours. Then we'll get 1 peso per 1 hour of work. Now, for the case of working hour method, meaning if the photocopier is kept on the warehouse and not performing any work, then the photocopier is not depreciated based on the working hours method. If the photocopier is made of some special material or some special metal that does not corrode, meaning if we just kept this photocopier on a warehouse, this photocopier will never depreciate. After say 10 years, the cost of the photocopier will still be intact at 11,000 pesos or its equivalent by that time. due to the adjustment and inflation, of course. Okay, so this is the depreciation rate per hour. Now, if we want to determine the total amount depreciated after printing for 5,000 hours, or say yes, for 5,000 hours, we simply multiply it by 5,000, then we get the total amount depreciated is 5,000, meaning this is the formula to determine the total amount depreciated. And to determine the book value, the original cost is 11 less the total amount depreciated. We get 6,000 as the book value after printing the 5,000 hours. I mean, after printing for 5,000 hours, cumulative 5,000 hours. So this is the formula to determine the book value. Okay, let us consider this problem. A lathe machine costs 300,000 with salvage value of 15,000 pesos. Is expected to last for 28,500 hours in a period of 5 years. In the first year of service, it was used for 8,000 hours. Compute the depreciation for the first year and the book value at the end of the first year. Okay, so here is your lathe machine. It costs 300,000 pesos now. After using it for 1 year, it has been used, or it has been working for 28,500 hours. I'm sorry, it has been working for 8,000 hours. If you plan to sell this lathe machine at the end of the year, what is the fair price? Okay, now I will illustrate that this machine life, or this machine is cost 300,000 now, and it has a life of 5 years. Now, if it has a life of 5 years and its salvage value is 15,000, it means that its cost of service is 285,000. This is based on the life of the machine. Now, since the problem also mentioned that the machine can last after working for 20,500 hours, then we can also use this analysis. The cost of the machine now 300,000. Its life based on the working hour method is 28,500 hours. The cost after life, or the scrap value 15,000, meaning the cost of service is 285,000. As you can see, we have different life here in terms of working hours and in terms of years. We will illustrate the difference and we'll compute the actual book value. Okay, here is our formula for the rate of depreciation, regardless of the kind of method, because all of the methods we have discussed earlier are all linear in nature. So, this is the depreciation rate, total depreciation, and the formula for the book value. And we have here is our computation. For based on linear method, or based on life, this is the rate of depreciation per year. 285,000, we divide it by 5 years, we get 57,000 pesos depreciated per year. Okay, what does it mean? Meaning, if this machine is kept in a warehouse, and even if this machine is not used, it will normally depreciate due to the corrosion and other damages due to through time. And the total cost due to that damage, or that corrosion, is 57,000 yearly. So if we determine the total depreciation after 1 year, we have 57,000 times 1, because there's only a year, and the total amount depreciated after a year is 57. If the original cost is 300,000 less the amount equivalent to that damages or depreciation is 243,000. Meaning, if we have kept this machine on the warehouse and not performing any work, its depreciation after a year is 243,000. I mean, the book value after a year it will be 243,000. Okay, now let us consider if we consider the depreciation based on the working hours. Here is the rate of depreciation per hour. We have 285,000 working hours total for this machine. We divide it by 28,500. I'm sorry. The cost of life or the cost of service of the machine, 285,000. We divide it by its total working hours. We get 10 peso per hour. That's the depreciation. But according to the problem, it has performed 8,000 hours for the first year, meaning we have 10 for every hour, and and it has worked for 8,000, meaning it has depreciated 80,000 based on the work. Compare the two amounts. Based on its life, it has depreciated 57,000. Based on the working hours, it has depreciated a higher amount of 80,000. In computing the depreciation, we are not actually going to add the two depreciation. We will not say that the total depreciation is 80 plus 57 or 137. In the method of depreciations, we will only select the one that is, we can say, the normal one. Since it has depreciated because the machine has actually performed work for 8,000, meaning it has actually depreciated 80,000. According to the life, it has depreciated 57, but according to the work, it has depreciated 80, meaning this lathe machine is overworked, meaning it has an actual depreciation of 80,000. Assuming that this machine has worked only for 1 hour for that year, 1 hour only, meaning this lathe machine has only depreciated 10 pesos. So meaning if the depreciation is 10 pesos, meaning the machine is not overworked, meaning the machine will depreciate based on the age. The total depreciation is 57. Okay, but since the machine has worked 8,000 for that hour, for that year, it is considered overworked, and this is the depreciation. Now, if we compute the total book value after 1 year, 300,000 less the amount of depreciation is 200,000 pesos. Compare the two book value. According to the working hours method, 220 is the book value. But according to the life, the book value is 243. Now, if you are the buyer of this lathe machine, which book value would you prefer? Well, we would prefer 220 because the machine has a total depreciation of 80,000 based on the work. It is overworked. Okay, another method of depreciation is called the SYD, or the sum of the year's digit. Assuming this is our photocopier again and the cost of this photocopier is 11,000, it is capable of delivering the service for 10 years. The cost of plastics and metals in this photocopier is 1,000. Okay, for the sum of years digit, our method of depreciation is done this way. First, we compute the total cost of service, 10,000. And then, we compute the sum of the digits. Because this photocopier has a life of 10 years, first we compute the sum of all of the digits of the year. First year, second, third, up to its last year, 10, which is in this case is 55. So if the number or if the life of the machine is lesser than 10, it will be easier to compute. But if the life of the machine is greater than 10 or more, it will be difficult to compute manually. You may use the formula to compute the life of the machine using this formula. I mean the sum of the years digit using this formula. This is the sum of an arithmetic series, as you may recall. Or you may also use the summation function of the calculator, summation of x from 1 to 10. The result will be the same. Okay, the depreciation rate per year, the depreciation per year is not uniform and it is equal to this formula, reverse digit divided by the sum, which I'm going to illustrate here in the other side. The total depreciation may be computed by summing up all of the depreciation year by year. Okay, and the book value may be computed using the same principle that the initial cost less the total depreciation is the book value. Here is the formula or the schedule for our depreciation. Now the photocopier is new and is not used. The book value is intact 11,000 pesos. After a year, after a year, the the photocopier will depreciate based on this proportion. 10, this is the reverse digit, because the digits here, as you can see, starts from 1 up to 10. When we count in reverse, we see here 10. So we have 10 divided by the sum of the year's digit, which is 55. So 55. So 10 out of 55 of the cost of service will depreciate. So meaning 10 out of 55 of cost of service 10,000. So we did not include 10,000 here because we don't have enough space. So 10 out of 55 of 10,000 is 1,818. So as you can see from the sum of years digit method of depreciation, the biggest depreciation occurs at the first year. And after depreciating 1,818, what is left is 9,182. 11,000 less this amount is 9,182. On the second year, the amount depreciated is now lesser. Next to 10 is 9. So we have 9 out of 55 of 10,000. So 9 over 55 times 10,000, we get 1,666, or a book value of 7,546. Now, as you can see, the depreciation for every year is actually decreasing. Why? Maybe it is based on the principle that a depreciated machine or a damaged machine does not depreciate so much. No? If we have a cell phone and it is so brand new, it has no scratches on its screen. By the time that it has a maybe small scratch, it will affect its price so much. That's why the first depreciation is higher. On the other case here, if you have a phone with some scratches and you add another scratches, the effect of the following scratches will not affect so much. Maybe that's the principle for the depreciation based on the sum of years stated. Until the 10th year. On the 10th year, the depreciation is the least. It is 1 out of 55 of the cost of service. What is left is the cost of plastics and metal, 1,000 pesos. Okay, let's try this. Determine the book value at the end of 4 years of a machine costing 20,000 pesos, having a serviceable life of 8 years and a salvage value of 2,000 at the end of that time. Use SYD method. Okay, the cost of the machine 20, life 8 years, cost of plastics and metals is 2,000. The cost of service is 20 less 2,000, 18,000. Now the depreciation can be computed first by summing up the years from 1 to 8 is 36, or summation of x from 1 to 8 is 36, or use the formula. Now, to compute the depreciation for that year, compute the reverse digit, divide it by the sum of the years stated, and compute the total amount depreciated by summing all the depreciation year by year, and compute the depreciation after after 4 years. Okay. So first, we compute the total amount depreciated. Okay. The total amount depreciated is the sum of the first, the second, the third, and the fourth. All of this quantity is equivalent to 8 over 36, 7 over 36, 6 over 36, and 5 over 36. Now the first depreciation, D1, this must be small letter D and with 1 here. It's a mistake. So D, small d, 1 is 8 out of 36 of 18,000 plus the second depreciation. I'm sorry, this is correct because we are computing the total depreciation. The first depreciation is this quantity. The second is 7 out of 36. The third is 6 out of 36 of 18,000. And the fourth is 5 out of 36. This is the total depreciation of the machine. Here we have written 8 plus 7 plus 6 plus 5 because this expression has a common factor of 36 and 18,000. So we move 876 and 5 out of the expression. So that's why we have here 8765. That is if you want to have a simpler computation. So the all divide by 36 times 18,000. So these two are equivalent. We can simply add all the years digit in reverse and then we divide by the sums of the years digit multiplied by the cost of service. And then the total depreciation is 13,000. Then we can compute the total book value by deducting 13,000 from the initial cost of 20,000. So we have 7,000 pesos. Okay, now let's proceed to the another method of depreciation. This is called the declining balance method. Assuming we have a photocopier, both at 11,000 pesos, and then this photocopier has a life of 10 years. If this photocopier uh, has plastics and metals in earth in it, of course, it will have a salvage value or scrap value. Assuming that the total cost of this photocopier, which is 11,000, will decline by 10% per year. What does that mean? Well, let's illustrate that to this depreciation schedule. Now, the photocopier is new and its book value is intact. But after a year, that amount will depreciate. So now the cost is 11,000. 11,000, this is the cost now. After a year, this amount will decrease by 10%, meaning the amount or the cost of this machine will become zero point 0.9 of the original amount. Because if we reduce it by 10%, meaning what is left is 90%. So we multiply 11,000 by 0.9, we get 11,000 times 0.9. And that will become 9,900. So 11,000 times 0.9, we get 9,900. Okay, next, on the following year, this amount will depreciate again by 10%, meaning only 90% of this cost will retain at the end of the second year. That is, the cost on the second year is equal to this quantity, since we have already two factors of 0.9. That is, on the second year, if you multiply 11,000 by 0.9 twice, we'll get 8,910, a difference of 990 from the previous book value. As you can observe, we are actually computing directly the book value and not the amount depreciated. That's the difference with the previous depreciation methods. So the direct computation applies to the book value. So on the third year, this total amount again will depreciate by 10%, meaning leaving only 90% of the cost at the end of the third year, and so on and so forth, up to the 10th year. On the 10th year, that would mean if the life of the machine is a variable number n, meaning in general, if the life of the machine is n, then we can compute that its book value at any period n is equal to the original amount times the total amount left, or the portion of the cost that is left, which is equal to 1 minus zero point 0.1, in this case is 0.9. Our k here is the rate of decline. 1 minus zero point 0.1 is 0.9. That's why we have 0.9 here. In general, this is our formula, raised to the power of n. So the first formula that we can compute using declining balance method is the book value. Now following, assuming if the book value on the third year is 8,019, and of course the book value at year 0 is 11,000, then by subtracting these two amounts, we can determine the total amount depreciated. So in order to determine the depreciation total, we simply subtract the amount or the book value now by the initial book value. If we want to determine the, the depreciation for that year, we compute the book value of the adjacent years and then subtract their amount. That will be the depreciation on that year. For example, we want to determine the depreciation on the third year. We compute the book value on the third, we compute the book value on the second year, and then we subtract the two amount. That's why we get here 891. Okay, let's proceed. A machine costing 720,000 pesos is estimated to have a life of 10 years. If the annual rate of depreciation is 25%, determine the total depreciation using the constant percentage method or declining balance method. Well, constant percentage suggests that it must be a declining balance method. Okay, so we have first to compute the total depreciation. Initial cost times 1 minus k raised to n, and computing the total depreciation, we compute the initial, we subtract initial cost by the total or the book value after n years. Okay, we have initial cost 720,000. The rate of decline 0.25. So this factor here is 0.75. Our n is 10 years. The total depreciation, meaning the total amount to be depreciated, leaving only the scrap value. So the total amount depreciated after a year, after its life of 10 years, CO is 720 less the quantity that is computed from here. That will be the total depreciation. Okay, let's proceed. A VOM has a selling price of 400 pesos. If the selling price is expected to decline at the rate of 10% per year due to obsolescence, what will be its selling price after 5 years? So after 5 years, selling price, meaning the book value, can be computed directly by the formula because the formula for declining balance is a direct and it's computing the book value. This is the formula to use to compute. Okay, compute the book value after 5 years. CO 400, 1 minus zero point 0.1 or zero point 0.9 raised to the power of 5. Okay, we are now on the sinking fund method of depreciation. What is a sinking fund method of depreciation? We'll illustrate that using this illustration. Suppose we have a photocopier And this photocopier costs 11,000 pesos brand new. And then this machine has a life of 10 years, and the cost of plastic and metals in it is 1,000 pesos. Meaning the cost of service of this machine, 11,000 less 1,000 is 10,000 pesos. Okay, now the depreciation of this machine based on the linear method of depreciation. I will review the linear method of depreciation. The cost of service, 10,000. If we distribute that amount for 10 years, then we will get the depreciation of 1,000 per year. That is, if we want to buy a new photocopier 10 years from now, we need to set aside 1,000 pesos per year for 10 years. We set aside 1,000, another 1,000, and for 10 years, the total amount set aside is 10,000 pesos. And then we sell the plastic or we sell the photocopier as scrap for 1,000. Then after 10 years, what we'll have is the scrap amount of 1,000 plus the total kept amount of 10,000, a total of 11,000 that is capable of buying a new photocopier. Okay, so this will be the depreciation if the method of depreciation is linear. But that is not the case because um, if we save the amount of money, say instead of setting aside 1,000, we put 1,000 in the bank. If we put 1,000 in the bank, this amount will earn interest. If we put this 1,000 in the bank, this will also earn interest. All of this amount, if placed on the bank, will earn an interest. Then it would mean that the total amount accumulated by this money in the bank, including the scrap amount of 1,000, is too much to buy a new photocopier. That would mean that the amount necessary to be kept aside or to be deposited in the bank is lesser than this amount. We'll illustrate that in the following illustration. So 10,000 plus 1,000 is 11,000. If there is no if we are only keeping aside the money. Sufficient. Okay, for the sinking fund method of depreciation, this is the concept now. Instead of saving 1,000 or keeping aside to a piggy bank, we keep the money in the bank such that this money will earn an interest. Now, we know the amount is lesser than 1,000, but we don't know the exact amount yet. Assuming that we deposited A amount, and then on the second year, we deposited another amount A to the bank, and the third year and up to the 10th year. This amount of money after withdrawal from the bank must be equal to how much? The cost of the photocopier by the time, assuming, is still 11,000 pesos. Meaning, if we sell the photocopier, by that time, it will cost 1,000. Now, what we need is only 10,000 in order for us to buy the photocopier. So, the amount A will accumulate for 9 years, and this is that amount. This amount will accumulate for 8 years in the bank. This one in 7 years, and so on and so forth. The last amount will not have time to accumulate at all because we deposited in the same day that we draw the amount. If we sum up all of this amount, that is the total amount withdrawable after a year or after 10 years, which is equal to this quantity. Now we know that this amount must be exactly the amount of 10,000 pesos because this is the amount necessary to buy a new photocopier after selling the photocopier as a scrap. So computing for the value of A, we get A 628. Okay, why 10,000 and not 11,000? Because the only amount we need to accumulate in the bank is only 10,000. We can get another 1,000 by selling the photocopier as scrap. So by selling the photocopier as scrap of 1,000, plus the 10,000 withdrawable amount from the bank, what we get is a total 11,000 pesos that is capable of buying a new photocopier. Okay, so here is now our general formula to compute for the amount necessary to deposit into the bank in order for us to buy a new photocopier. The amount to be deposited a year raised to the power of the life of the photocopier. Okay, it must be equal to the amount of the cost of service. We are saving for the replacement of the machine and we are saving for the cost of service, the 10,000. So if we divide both sides by A, if we divide both sides by this expression, we will divide also this one by that expression. What we get is that A equals, well, this is just a mathematical manipulation or algebraic manipulation. We got this quantity here. So CO minus CL divide this quantity is that CO minus CL times I over 1 plus I raised to L minus 1. A is the amount necessary to be deposited in the bank so that we can accumulate the same amount as 10,000 after the life of the machine. Now, since this amount of money is used to buy new photocopier, then this amount is equivalent to the amount depreciated by the machine. So this is the formula for the rate of depreciation if we use the sinking fund method. The sinking fund method is the true method of depreciation because it uses the principle of the cost of money. Other methods of depreciations are used only for the purpose of simplicity. Okay, so if we want to compute the total amount depreciated, so in this case, if we have the total amount depreciated per year is D, which is equivalent to the amount deposited, then we can also compute the total future amount equivalent. For example, after depositing money in the bank for 4 years, what is the total amount accumulated by that amount? Okay, assuming on the first year you deposited D, on the second year you deposited D, in the third, in the fourth, or the amount equivalent to the depreciation. Now, if we determine what is the total depreciation after 4 years, the total depreciation after 4 years may be computed using the formula of annuity, because as you can see, this is actually an annuity. Our formula for annuity is the annuity times this quantity. Okay, so instead of A, we replace it by the amount D because the amount deposited is actually the amount depreciation and the future amount is actually the total amount depreciated. This is the formula for the total depreciation of the photocopier or the machine under sinking fund method. Now we can also determine the book value by deducting the total amount depreciated from the initial cost of the machine. Okay, let us now proceed. A firm bought an equipment for 56,000 pesos. Other expenses, including installation, amounted to 4,000 pesos. The equipment is expected to have a life of 16 years with a salvage value of 10% of the original cost. Determine the book value at the end of 12 years using sinking fund method of 12% interest. Okay, the initial cost of our equipment is equal to 56,000 pesos. This is the cost of the equipment plus the installation cost of 4,000 pesos. So the initial cost of the equipment is 60,000 pesos. Okay, the life of this equipment is 16 years, and then the salvage value of this equipment is 10% of the initial cost. The original cost is 60,000, so the salvage value is 6,000 pesos. So if we are going to determine the cost of service, we have the 60,000 less the salvage value, we have 54,000 pesos. Okay, the question of the problem is the book value at the end of the 12 years. So using sinking fund method of depreciation, we assume that at the end of the 16th year, we must be able to produce another 54,000 pesos. We produce 54,000 pesos and then we sell the equipment as scrap for 6,000 pesos. That's a total of 60,000 pesos capable of installing a new equipment. In order for us to accumulate 54,000 pesos, we must set aside amount today and deposit that to the bank at an interest rate of 12%. The question is, how much is that money to be set aside yearly? So we will use the annuity formula, assuming that the interest offered by the bank is 12%, then the depreciation or the annuity or the amount to be deposited to the bank using the annuity formula is equal to this value. The depreciation or the amount deposited to the bank yearly is 1,263. It is considered depreciation because the amount deposited in the bank is used to be uh, is used for repurchase of the equipment. Okay, so since the question is the total book value at the end of the 12 years, we're going to determine the total amount depreciated after 12 years first. That is, we need to determine the total amount deposited in the bank, including its interest, for 12 years. Well, using the total for the future worth of annuity formula, which is this one. The annuity is the amount deposited in the bank, which is the depreciation, times the future worth factor of the annuity. The total amount accumulated in the bank, including the interest, is the total amount depreciated by the machine. Substituting the values, we have D 1,263, our I is 12%, our N is 12. So we can now compute for the total amount depreciated. And since we are computing for the book value, whatever amount is computed for the depreciation, we simply subtract that from the 60,000 pesos in order for us to get the book value at the 12th year. Okay, I am now showing you the summary of the method of depreciations. For the method of depreciation, we have linear, life, or service output method, of the output or the working method, or the working hours method. They all have the same formula. For the rate of depreciation, we have this formula. For the total depreciation, we have that formula. And for the book value, we also have this formula. Now, for the sinking fund method of depreciation, the rate of depreciation is this formula. As you can see, this looks a little bit different from our illustration. Well, simply transfer your I on the numerator, then we'll have the same formula as what I have discussed earlier. The total depreciation is this formula. Well, this is the annuity, the depreciation, and N is the life of the machine. The book value is that formula. For the sum of years digit, we have this formula. Um, well, you may refer to our formula handout to determine what is meant by this asterisk here. Anyway, you can use the principle in order to compute the depreciation using the sum of years digit. For the declining balance method, we have this formula. To determine the rate of depreciation, we subtract the adjacent book value, that is the rate of depreciation for that year. For the total depreciation, we deduct the depreciation for that year from the initial cost. And for the book value, this is a direct formula, and this is the very first formula that we can use for declining balance method. And for the double declining balance method, the formula is the same, except that the K is computed from this formula. The rate of decline is computed by dividing 2 by its life. Assuming, for example, that the life is 20 years, then the rate of decline is 10%. 2 divided by 20 is 10%.